So hello everyone, in this video we want to look into some ways how you can automatize the generation of Voronoi cells based on some basic starting geometry and then create little connecting devices like this here between your existing geometries. Hope you will have some fun and you will definitely learn a little bit about Grasshopper by yourself, because in between we do short pauses for you to exercise the use of Grasshopper on your own. Hope you'll enjoy. Okay, let's get started. In this video we want to solve some little tasks. So you have to think a little bit, pause the video at certain points, and then get familiar with the commands in Rhino. And first thing I want you to do is create a Voronoi again. And we've done that in a couple of other videos. If you haven't watched them, please check them out. So if you go to Voronoi 3D, we place that, and what I want you to do this time is, instead of using a box from Rhino, I want you to think about a way how you can use a box from Grasshopper. And little hint, you might want to go to the Surface tab over here and look a little bit around where you might find tools to design a box. There are several ways you can do that. You can choose any kind of box, but I would recommend try to figure out a way how you can define the size of the box to be 20 by 20 by 20. And then from there we want to populate that box with points. And therefore, again a little tip, you might want to go to the tab Vector and find something that helps you to populate an existing box with points. And to give you a number of how many points we want to have in that box, I would suggest let's go for 10. Should be relatively easy. So pause the video now and try to do that. Have fun, and afterwards I will show you the solution, but I want you to definitely get your head around it by yourself. Okay, I hope you were able to manage that. Let's have a look together how we could do that. So we go to Surface, and then we find the box in primitives. There are several ways you can define a box, and I would suggest we go for the center box here, because that allows us to really specifically define the sizes. And we can do that, we have already seen that, by a number slider. So we create a number slider by double clicking and typing the number 20. And actually we do that, we don't need several of them, we can just plug in the 20 into all of these, which gives us a box of 20 by 20 by 20. So we bring it into the Voronoi, and now we want to populate that box with points. Again, we have seen that. Vector was my hint. If you go to Grid, you will find Populate 3D. Let's bring that in. So what does it need? It asks us for a region and a count. Region currently is already, you see if you zoom in, there are some points in a box, so there's a predefined box, but we want to bring in our box. So now you see that's definitely more than 10 points. The count is currently set to 100. Instead we want to go to 10. Plug that in, and now we have our 10 points, and we just have to bring in these points. If you hover here, you see locally defined 10 values. Bring them in here. Let's hide these for now. You might notice that the number slider sometimes brings in the number somewhere in the middle of the number sliders, and if you go to round things like 10, 100, 1000, it most likely brings it to the end of the slider. If you want to change the slider anyway to have more points, a higher count, you just double click here on the name number slider, and you can change the number to, for instance, 50 over here. Press OK, and now you have the control to change the number again. Okay, great. I hope you were all able to manage that. Let's group that and create a copy of this, because we will build up our next task based on this little script that we just developed. So go over here, Control C, Control V to bring in that again. Make sure you hide this one here by turning the preview off, by right click and then preview off. And now I want you to exchange the populate point, and instead I want you to, let's turn on the box here for a minute, and instead I want you to bring in points into this box by deriving them or setting points from a curve. So you have to draw a curve. Maybe you have to go to the top view, draw one curve over here, and actually let's not only do that by, and now I want you to bring in points from that specific curve. Maybe we move even some of the points up and down, so it really travels a long way through our box. Maybe you can even rotate that a little bit. Okay, so again, little hint, for sure you have to go into curve, you have to bring in the curve into Rhino by, again, just double clicking curve, and now we want to derive points from that curve. Again, pause that video at this point and figure it out by yourself, and then afterwards we will have to look at it together. Okay, I hope you managed. If you didn't manage, let's try together. So first we bring in the curve, set one curve, so we have the curve in here, go to division, divide curve, bring it in here, plug in the curve over here. You see we already have points, and now let's bring in these points over here into the Voronoi cell. You see it creates, let's turn on this box for now, you see it creates a very interesting way of Voronoi cells. The cells follow this curve, and of course you can, again, the count is set to 10. Let's maybe try a little bit higher count. So you bring in a slider by just typing the number, and you can see we can play a little bit around with it. Obviously you're not limited to do that with one curve. Let's see what happens if we do that with, let's say, 3 curves. And we copy this curve a little bit, we move it around. Or let's maybe use 2 parallel curves. So I just create a parallel curve here. So now we have 3 curves, as you see here. As you can see here. Let's bring these 3 curves into this one here. Right click, set multiple curves. Now you see that becomes a little bit messy, and suddenly we have this curve here which is now dashed. And this is because the data structure, or the flow of data between these 2 components or battery has changed. Let's have a look at that. If we go to parameters over here and we go to utility, you might find the parameter viewer. Let's bring that into our canvas. And if we plug in the points from the divide curve component, we see that there's a data with 3 branches. So instead, what happened here is we don't have one list of points that is traveling here. Instead, we have 3 lists with 22 points. And 22 is actually this number. If I set that down to 11, no, it's 12 points. Again, remember the divide curve component divides the curve into segments, and from that segments, which are 11 segments, it can derive 12 different points. So if you double click on that, that's even a more visual way of showing you. So you see that this is the flow of data. Instead of having one data flow, we have 3 flows of data, these 3 lists. If you want to have a look at this specific data, you can always go to the panel over here in parameters. Let's bring that in, plug in the points here on the left side, and if we extend that a little bit, you see there are 3 lists divided by this darker row here in the rows. In each row there's the point, but then there are 3 lists. One list, second list, and a third list. And if we want, so that also happens here with the Voronoi cells. So there are, for each curve, there's a different set of Voronoi cells now. And you might notice that there's this 0 here in front of the different lists. So actually it should be 0, 1, and 2. We can make that a little bit more clear if we go here and we press simplify. Now, yeah, it becomes a little bit easier. Okay, so how can we make these 3 lists into 1 list? There's an easy way in Grasshopper. You just go on that component here, right click, and you can flatten any kind of data stream to become again 1 list. So bam, you see now it's data with 1 branch. If we double click again, it visualizes it like that. If we click again, we see now it's 1 list with 36 items. And if we go here in our panel, we don't see any dark bar dividing our lists. Seems like there's a small 2 coincident points were ignored. I don't know where these are. Maybe these are overlapping. So yeah, a little error. Yeah, so this gave us our more complex but more controlled Voronoi cells now. Yeah, you can imagine now you can really go and manipulate the points to kind of design your Voronoi cells. Okay, so next thing I want you to do, and we can maybe get rid of these and group this ones here, group, and copy that again. You can just left click onto a component and hold the Alt button and move it down. This will create a copy. Let's again turn off the preview over here. And now I want you to move your cells in the X direction, all of the cells. I want you to move from here, and I would say like 40 centimeters over here. So what, again, I give you some hints to do that. You have definitely to use a transform, and there are several ways. Maybe test a few of them, see what works best for you. And you might again want to use a vector to define the direction for your movement. And again, it might be, try that in the X. And there's also a little hint, there is something called a vector, which you can define by a number. So yeah, please try that. Try to move all of the cells. It will create a copy over here, like 30 to 40 centimeters over here. Okay, try it out on yourself, and then we'll look at the solution. Okay, I hope you found it yourself. If not, let's have a look together. Go to Transform, and there you find Euclidean. We already in another video covered the orient, but you see there are a lot of different ways how you can transform objects. And we want to use the move command. Let's bring that in. And it can move any geometry. And you see now it moves it up. Why is that? If we go to the motion, it says it has a translation vector, which is now 0, 0, 10. So it moves it up 10 centimeters in our case. But instead we want to move it in the X direction. So let's go to vector and see what kind of vector we could use. So you see there's a unit X vector. Let's bring that in, plug it in here, and you see it just moves it a tiny bit. And yeah, but we see there's also the vector, which is a number, a unit to multiply. And let's type 40 and try what happens if we bring in another number over here. Aha! So we create a copy of these. And this copy is really a copy. So if I move something over here, you see how the cells also change in the other, in the moved cells. And let's say I don't want to have a copy of all of them, but just specific ones. I introduce you now to something called sets or lists item. So there's something we've seen now. These components always transmit data, which is often organized in lists. So there's a way you can access a specific item on that list. So let's go to list and list item. Click on that. And this allows us to receive a specific item from that list. I would recommend you now to turn off the preview of this one. And now you see it just selected one item. And there's another terminology you have to get familiar with, which is the index. So in the list, maybe let me bring in this again here, the panel. You see there's this little number in front of the objects in your list. This is the index. So currently we are, and just a little thing about computers don't start counting from 1 but from 0. So instead of counting from here, from 1, it starts by 0. So the first index is 0. We can easily bring a number slider in here to change which index we pick. So you see we can go through these objects. Okay, great. And now let's try another little thing, and that will be, let's try to bring a curve, to project a curve onto this block here. So there's a command called project. You bring that in. You see it's asking us for brep, which we get from over here. And then it asks us for a curve and a direction. So now you have to really specify, you have to imagine it projects really the curve from one direction, so that is based on your vector, and you have to really make sure that you are that you project the curve in the right direction. So again, pause the video, get in a curve, draw a curve that can be projected, and again, as a hint, these are, for instance, very easy directions. So you have to draw a curve and try to project it. Let's say you draw it in the top view, then you have to project it at the Z vector most likely. If you draw it from the right or front, you have to use a different vector. So yeah, please have a try to use Grasshopper to project something onto an existing brep. Okay. So again, let's try to do that. Let's say you have drawn a curve in the top view, and maybe we use a different, let's draw it here. So you see this curve doesn't hit that object at the moment. It's floating above. So we bring in this curve into our Grasshopper canvas, set one curve, plug it in here, and we see that already works because it will anyway project at the Z direction. You can obviously change that by specifying that over here to make sure it really projects at these. Let's delete that for a moment. So we have this one object over here, and now we want to do that with another object, with another cell. Let's copy all these cells here, Command C, Command V. Why doesn't it work? C, V. Okay. And now we want to do that on another cell. So we search for another cell, maybe this one. And you see it doesn't hit that object. So instead we could draw another curve. But of course we could also try to draw the curve always based on the center point of this object here. So try to figure out how you can draw a circle based on the center point of this item. And again, little hint, so circle, yeah, we want to replace this curve here in both cases. And instead, we want to draw it based on the center point. Yeah, so you know that we are working with surfaces, and you find some tools that might allow you to find the center point. Let me give you a hint again. It's most likely the volume. Yeah, so try how you can get the volume to draw a circle always based on the center point of your curve. And again, you can specify the radius of the circle over here. Pause again, try to work it yourself, and then we'll figure out the solution right afterward. But it's very crucial for you to try it yourself so you get an understanding and learn actually Grasshopper. Okay, so how do we get the center point of this thing here? We bring in the volume, plug it in over here. Sorry, this gets a bit messy now. Let's clean it up a little bit. So we have a centroid. You see that over here? This is a center point. And now this will draw a circle based on this center point. Obviously the radius we may want to change. Maybe we go for 11, which would be probably quite tall. Yeah, let's find a different size. Maybe 5 will be good. Yeah, so I just changed the number slider scale. And now instead of our rhino curve, we want to use this one, this circle. And again, it gets projected based on the center point and based on the radius. So we can change the radius over here now. And so yeah, maybe we delete this one here from previous. And again, we group all of these here. We don't need this anymore. So all of these components, we group them. And again, we copy them, group them again. Because yeah, now you have to again search for the other item and see how it directly projects the circle onto this thing here. Okay, and now one more thing that we want to test. Let's maybe search for some cells where it might make a little bit more. And now let's try to loft between two of these between the projected curves. So what you have to do for that is to bring in the loft command, and now we want to loft between these curves, and again hold the shift button and these curves. And you see, yeah, it creates, in a lot of cases it will not make a lot of sense, so we have to probably change the way I mean, the things have to make a little bit more sense how they are organized. But you see it creates these weird shapes in between your objects, all automatically. Which would be a very weird connector. There's a little hint, you can always change the order of these curves. So let's say you want to reverse that, you see now this thing goes the other way. You can also do that over here, which looks a little bit more weird. But you can constantly click through these things. Again, I think in my case the reverse didn't make a lot of sense, so let's click that back. So the reverse basically flips the order of the curves, the list, the items in the list basically. So yeah, let's see how that would work if we just want to have the loft between one of these curves. You remember there was something that can help us to receive a specific item. Try how you could do that. And pause again, and then we look at it together. Okay, great. So I hope you solved that. If not, we want to try it with a list item. So plug in the list item here, and now you see it just selects one curve. And obviously we can just change the index if we want it to be the other one. Let's copy this list item and do it also for the lower projected curve. And bring these two in here by holding the shift button again. And then again, you could change the index if you just go here and set the integer to 1, press OK, and you see now it will loft between this curve and the other curve. You can do the same over here, 1, press OK. And probably here and again, another easy way is just reverse this. This will create another curve like that. And still you can shift through your list over here, and it will always automatically create these objects here. So I hope you were able to follow most of these. It became a little bit complex, but it shows you also how one develops such a script over the course. Yeah. So you always have to figure out a little bit what you actually want to do, and not saying that this is the smartest way to create, for instance, something like connectors between geometries. So you have to think a little bit in more depth around it, but it shows how you can build generative geometries that are parametrically based on previous steps. So I hope you enjoyed it. If you have questions, just let me know. And I hope you learned a little bit about Grasshopper by yourself. You explored a few of the components that are available to you, and you also had a little bit of fun. Hope to see you soon, and thank you very much for listening.